And you can see here that it says that we're going to need to convert between moles and particles. And to do that, we're going to need a conversion factor based on the equivalent statement of 1 mole is equal to 6.02 times 10 to the 23 particles. And you can use that equivalent statement as a fraction, and that fraction can be in either orientation. So you can have 1 mole over 6.02 times 10 to the 23, or 6.02 times 10 to the 23 over 1 mole. Okay, and we should have the word particles here, so we have a unit there. And I'm going to use the generic term of particles here because we don't know what kind of substance we're working with. But a conversion fraction like these, you can use them in either direction, whichever direction you'll need to in the particular problems you're going to see, because these are equivalents, and of course because they're equal, 6.02 times 10 to the 23 is equal to 1 mole. Either way you have this fraction, it's equal to the quantity of 1. Sometimes you're going to have to convert between moles and mass, and the conversion factor that you're going to have to use here is 1 mole is equal to the molar mass, which you'll have to get from the periodic table, and it is dependent on the substance in the question. So you'll set up a fraction, and the fraction can be either direction. It can be 1 mole over the molar mass or molar mass over 1 mole, depending on which problem you need to do, or whichever problem is given to you. If you have to convert between particles and mass, this is going to be a 2-step problem, and you're going to need to use 2 conversion fractions, one of each of the types that we just talked about. Okay, you see here this is a visual representation of the strategy that you might use to solve problems. There are 3 things that you can convert moles from. We're only going to discuss 2 for now. You can convert moles. You can convert moles to particles, and to do that you need to use a conversion fraction using 1 mole is equal to 6.02 times 10 to the 23 particles. Or you can convert between moles and grams using the conversion fraction 1 mole is equal to the molar mass from the periodic table. But if you need to go from grams to particles or particles to grams, that's where you're going to need 2 conversion fractions, one using the molar mass and the other one using Avogadro's number. So this is kind of a handy visual representation to help keep track of where you are in your problems. So let's try a few together so you'll understand what I'm talking about. Converting 5.0 grams of hydrogen to moles. All right, so starting with the number given to you, 5.0 grams, what we want to do here is convert that to moles. So setting up a conversion fraction, I would recommend you start by putting a multiplication sign and a fraction bar. The first thing you're going to want to do is put the unit of grams in the bottom so that it'll cancel with the unit of grams that you started with. And you can go from grams directly to moles. And before I go on with this problem, I'm going to go back and show you what I mean on our map here. We started with a number that was in grams. We're trying to go to moles. So all I need is the 1 mole is equal to the molar mass from the periodic table fraction. So this is just a single step problem, a single fraction problem. And when you're doing these conversion fractions, you're always going to have the number 1 next to the mole. And then the number down here is going to come from the periodic table. So hydrogen, if you add up the molar mass from hydrogen in the periodic table, it is 2.0. And we're going to round those molar masses to the nearest tenth. So this becomes simply 5 divided by 2, which is 2.5. Okay, grams cancel, leaving us with a unit of moles. All right, so in problem number 2, we're going to be converting 636 moles of water to grams. So again, in these problems, always start with the number that you are given. In this case, it's 636 moles. And I'm going to step us back to the mole map right here. Here we're starting in moles, and now we're trying to get to grams. So again, we're going to have to use that molar mass conversion from the periodic table. So this is just going to be a single step problem. Going back to the problem, 636 moles, we're going to have a single conversion fraction. We're going to put the unit of moles in the denominator so it'll cancel with the moles that we were given. And we're going to put grams up in the numerator. Now the numbers that fill in here, you're always going to put 1 next to the mole because it's always 1 mole is equal to some mass. And so this is the molar mass from the periodic table. If you add up the molar mass of hydrogen and oxygen, it works out to 18.0 grams. So what we'll have here is moles will cancel, and you will end up with 636 times 18 in your calculator, which works out to 11,448 grams. But this is awkward because you have 3 sig figs to start with, and you have 5 sig figs in your answer. So rounding this answer to 3 sig figs would be 114 or 11,400 grams. So that's the best answer rounded to the proper number of sig figs for that number. All right, problems number 3 and 4. Number 3, we're starting with a certain number of molecules and we're trying to convert it to moles. So if we take a look, I'm going to go back and take a look at our mole map here. And in this problem, let's get this erased so we can see what's going on here. In this problem, we are starting in molecules, which is a particle, and we're trying to convert it to moles. So that's just a single step problem, and you're going to have to use Avogadro's number to help you do it. So that's what that mole map is supposed to help you see how to do these problems. All right, so single step problem, start with the number you're given, 7.8 times 10 to the 20 molecules. One step problem, so set up a single fraction. The unit of molecules will go in the denominator. We're trying to go to moles, so we'll put moles up top. You're always going to have 1 next to the mole. 1 mole is going to be equal to 6.02 times 10 to the 23 molecules. We'll see that molecules will cancel, and when you multiply 7.8 times 10 to the 20 divided by 6.02 times 10 to the 23, make sure you put parentheses around those scientific notation numbers, or else you will have order of operations problems and you'll get the wrong answer. But this works out to be to the proper number of sig figs. 2 sig figs to start, so we should end up with 2 sig figs to end. You'll get 0.0013, and the unit there is moles. Number 4, we are starting with 548 moles, and we're trying to convert that to molecule. So it's really just the reverse conversion of what we just did. Starting with a number given, 548 moles. It's going to be a single step problem. I'm going to put moles in the denominator and molecules in the numerator. The equivalent statements are always 1 mole is equal to something. So 1 mole is equal to 6.02 times 10 to the 23. Moles will cancel, and you'll get in your calculator an answer that we're going to make sure it has 3 significant figures. Should work out to 3.30 times 10 to the 26 molecules. That's a 6. Problems 5 and 6 are a little bit more complex. They're going to be 2-step problems, and I know that because we're going from molecules to grams. So we have to do this in 2 steps. If you go back and look at your mole map, you can see that molecules and grams, the only way you can do those problems is you have to convert to moles first. So start with the number you're given, 9.6 times 10 to the 25 molecules. You'll set up your first conversion fraction. We'll put molecules in the denominator because that's what you're starting with and that's what you want to cancel out right away. You have to convert it to moles. So filling in the numbers here, you always have 1 mole is equal to something. And since it's molecules, it's 1 mole is equal to 6.02 times 10 to the 23 molecules. If we left the problem right here, molecules would cancel and your unit left over would be moles. But we don't want to go to moles, we want to go to grams. So set up a second conversion fraction. I'm going to put moles in the denominator, so it'll cancel with the moles that's right there. And I'm going to put grams up top. Remember, it's always 1 mole is equal to something. So 1 mole is equal to the grams. From the periodic table, you got to add up the molar mass for NH3. It works out to 17.0 grams if you add it up correctly. Moles will cancel. Your final unit will be in grams. You should round your answer to have 2 significant figures. And the answer is, when it's rounded to the proper number of significant figures, it should be 2,700 grams. Number 6, we're converting 0.025 grams to molecules. So again, this is going to be a 2-step problem. We're going to have to convert to the mole first. So again, you start with the number 0.025 grams. You set up your first conversion fraction. The number, or the unit that goes into the denominator, is the unit that you want to cancel that you started with. And like I said, you have to convert to the mole first, so that would be the conversion fraction units, moles over grams. Remember, it's always 1 mole is equal to some number. In this case, this is molar mass, so we have to look up and know that the molar mass of KCl is 74.6 to the nearest tenth. So 74.6 will go in the denominator. If we leave the problem like this, our final unit would be moles, which is not what we're trying to do. We're trying to get to molecules. So you set up a second fraction. We're going to put the unit of moles in the denominator, so it'll cancel, and the unit of molecules in the numerator. Remember, the numbers that go into these fractions, it's always 1 mole is equal to some number. In this case, 6.02 times 10 to the 23 molecules. Moles will cancel out with each other, so our final unit will be molecules. And we should round it to a total of 2 significant figures, because that's what we started with. And if this is done correctly in your calculator, 2.0 times 10 to the 20. And I just realized my mistake here. This is not molecules. You have it written as formula units, which is a better descriptor of this substance because it's ionic. So if you caught me already, good for you. And so this is 2.0 times 10 to the 20 formula units. 2 sig figs is 2.0 times 10 to the 20 is the entire answer. 2.0 times 10 to the 20. All right, when you return, the next thing that we're going to get to is more practice with these molar conversions. So we will see you in the classroom.